Hey guys, I know you're working on your stoichiometry of baking soda lab reports. Excuse me. And I know a lot of you were feeling kind of stressed out because we looked at this, like, the whole stoichiometry thing that really just came out of nowhere and just feels really weird. And we haven't had a chance to work on it during class the way we normally do, so that you guys kind of build up to the point where you're like, yeah, this idea makes sense and I can use it and all that stuff. We're not there on this idea, but you guys have a need to be able to predict, like, okay, I got this much CO2 out of my reaction, and I'm supposed to compare what I actually got to what I should have gotten based on the reaction that I ran. And until you can just do the math on that and get a number to compare your number to and see how well you did, see how accurate you were compared to the prediction, you can't function on that level. So this is not ideal, where you would use this math without really knowing, like, where it's coming from. But this is how we're going to do it. So I'm just going to teach you the math. It's just going to feel like you're a human calculator. And for right now, that's what you are. You're just trying to find out, okay, if I put in this much baking soda, how much CO2 should I have gotten out the other end? And is that what I got? Or did I get some different number? And then you can do your usual thing where you compare yours with what you should have gotten. And then you kind of run through, like, okay, where could I have gone wrong? How could I have made my experiment better? Could I have come up with a better setup? And so on and so on. So what we're looking at here is we're looking at the reaction that you did. You've got your baking soda. So that is, let me just get a different color here. That's this. So here's your baking soda. And when you mix it with vinegar, you get all these things over here on the right side. And the one we're most interested in is the CO2, the carbon dioxide, because that's what you measured. And you were trying to figure out a way to capture it or to figure out how much of it there was. Some of you guys got a mass, some of you got a volume. You went about it lots of different ways. So now you have a number for how much CO2 came out. And we did talk a little bit about this. And so you've got some mass of CO2 that came out the other end of this reaction, and you're trying to figure out, is that what you should have gotten? So, let's say, for instance, that you put in 2 grams of the baking soda, right? So you know what you started with, and you're trying to figure out, like, okay, so what is that going to give me for grams of CO2? So this is the, predicted amount that you should have gotten. It's not what you actually got. So you got some kind of number for the actual amount of CO2. Maybe you got like 0.306 grams or something like that. And you now need the quote correct number to compare that to. So the problem is, when you look at your chemical reaction, what your chemical reaction can tell you is how many molecules are involved. So we've got this thing that says, we talked about this, and this part, is making sense to you guys. For every one of these molecules that you throw into this reaction, you'll get one of these CO2s. So if I told you you have one baking soda molecule available, then you could predict from looking at the reaction, well, then I'm able to get one CO2 out the other end. If you have 10 baking soda molecules, you can get 10 CO2s out the other end, and so on and so on. And we did talk a little bit about how a mole is just a really big number. So if you have a mole of baking soda molecules, you should predict that you'll get a mole of CO2 molecules out the other end. The problem is we don't have any kind of machine that'll read out how many moles you put in or how many molecules you put in. All we have is a scale. And the scale tells you how much, tells you what mass you put in. So we're going to have to try and kind of indirectly figure out, all right, based on that mass that I put in, what should I predict comes out the other end in terms of CO2? So that's where we're going to use these numbers to try and figure that out. So I'm going to clear away some of this stuff, and I'm just going to show you guys the very, algorithmic way of doing this. It is not reflective of you, being expected to understand what you're doing at this point. And normally I would not tolerate that. But since you guys just need a number to compare to, that's how we're going to do this. So I'm just going to show you how this works. And then you're just going to have to kind of relax and go with it and know that by the end of the semester, and the remaining time we have together, you're going to get a better understanding of this. So the way we're going to do this is we're going to say, okay, I've got 2 grams of baking soda that I put into my reaction. And that's a mass, but I want to know how many molecules that is. So that's essentially a conversion, right? So you're going from a mass to a number of molecules. So anytime we're doing a conversion, we're going to do something like that. And we're going to have this. And so I'm going to measure how many molecules I have in moles. So that's what I'm trying to convert into. Now, conveniently, when we met in class, we built these conversion factors because you guys figured out, what's the mass of a baking soda molecule. You broke it down into its component parts and you did all that stuff. And so now, without having the fundamental conceptual understanding, we're just going to use that math and we're just going to go with it against every instinct and fiber in my body, but we're going to do it. All right, so if we're just doing this as a conversion, we're trying to get out of grams and into moles, because moles is a number of particles, and that's what we want to know. We want to know how many particles of baking soda did we provide to this reaction. So we're going to do this setup. We know that if we put grams down here and moles up here, then my units will cancel. So our typical kind of conversion setup. And then this conversion factor that we built is saying 1 mole of baking soda molecules weighs this many grams. So then you're going to do out your calculation. I need to get my calculator. Ow, jeez. Okay. All right, so I'm going to do that out. So I'm just going to do 2 divided by 84.007. And I get 0.024 moles. So that's telling me, all right, I already knew that I put 2 grams of baking soda into my reaction. Now I know how many baking soda molecules that actually was. It's 0.024 moles of baking soda molecules. All right, so my reaction told me however many baking soda molecules I started with, I'm able to generate, if the reaction runs perfectly with no error whatsoever and nothing gets lost along the way, I should have exactly the same number of carbon dioxide molecules come out the other end. So that's going to tell me, all right, so this is both how many, oh my God, it's going to take me a while, but I always do this. I always label what I'm looking at here. How many baking soda molecules I started with. And you're going to do that for your number. So if you started with exactly 2.00 grams of baking soda, then I've done your math for you and you're all set. If not, then you're gonna have to do that calculation yourself. So I'm gonna clear us a little space here. All right, so that's how many baking soda molecules I started with, and that means that since we looked at our reaction and said, okay, it's a 1-to-1 ratio, every baking soda molecule should generate 1 carbon dioxide molecule. Well, that means that's going to equal how many CO2 molecules I get at the end. So this is the number that, we're going to compare your number to. So I know that now. So I'm saying, okay, I'm going to take that number and I'm going to say, all right, this is what I expect. I expect that many moles of CO2 to come out the other end. But now I'm like, okay, well, did it come out the other end? Is that what actually I ended up with? Whether I captured it in a balloon or let it go off into the air. How does that compare with what you actually got in your experiment? So now I got to kind of reconvert, because now I've got a number of molecules, but I want to know what that pile of molecules would weigh so I can find out if that's what I had at the end of my reaction. So I know I should have gotten that many moles. I want to know what that pile would weigh. And we built this conversion factor as well last time, where you guys added up what would a mole of carbon dioxide molecules weigh. So I'm looking at this and I'm like, okay, so I should expect 0.024 moles of CO2 at the end. If 1 mole of CO2 weighs 44.01 grams, I know that I didn't end up with a full mole of CO2 molecules at the end, because that would have weighed 44.01 grams, and I didn't get, I don't have anything close to that. So I can use this as my conversion factor to figure this out. So I'll just kind of scooch this over a little bit. 44.01 grams is what 1 mole of CO2 weighs. And I clear this away. So it feels a little weird because it almost feels like you're doing the same conversion in one direction and then just reversing it. But as we build up to the understanding of this, oops, let's not erase the whole thing, it's going to make more sense. So if I've set this up this way, moles is going to cancel, and then I'm going to have just grams of CO2. Gotta remind myself what I'm looking at there. Grams of CO2 that I should have gotten at the end of my reaction. So if I do that out, I'm going to do 0.024 times 44.01. I'm going to get 1.056 grams of CO2. So that's telling me what I should have gotten. So you have to do that whole math for yourself. Again, if you used exactly 2.00 grams of CO2, then I've done the math for you. So you just need to make sure you've kind of recorded how this math works in your lab report and relax about necessarily understanding it. If you had some number other than 2.0 grams of baking soda to start, then you need to do this process for yourself. So you got to figure out, okay, how many moles of baking soda did I put in based on your mass of baking soda that you put in. Run this whole thing that I just showed you on your numbers, and then you'll have a number. So now we've got this thing, and this is what we were targeting. We just needed a number to compare your number to. You got a certain mass of CO2 out of your experiment, and the frustration was, okay, I'm supposed to compare that with what I should have gotten, what I would predict I would have gotten, what the reaction says I should have gotten. This is the process where you get that number. So once you have a number like this, it's either literally this number or your number that you calculated, then you're going to look at what you actually got, and you're going to do the thing you've done all semester. Like, I'm going to compare what I actually got to what I should have gotten, and that's going to tell me my error. And then once you know your error, then you go into that whole process of, okay, if it wasn't exactly what I should have gotten, where did I potentially go wrong? Are there any points in my experiment where I expect I might have lost some material, or where I couldn't account for something, or where we wish we had a different setup? And that's where it gets kind of more interesting. So, but before you can go into all that, you have to have that comparison point. So this is the math behind getting to the comparison point. Try this with your own numbers. Don't worry too much about the weirdness of the mole thing. You're just targeting something that you can compare to, and then I'll build you guys up. You guys are superb at working on these ideas in class. You just haven't had the chance to do that with this thing yet. So we'll try that in the remaining weeks that we have together. And good luck on these lab reports. And as always, just let me know if there's something that's not making sense, and I can absolutely help you with it. See you soon, guys.